Hello class. So today we're going to go ahead and practice with slanted asymptotes. So the only difference here from what we learned yesterday is that we go ahead and find out what's going on here. So assuming we got rational function where we got a polynomial in the numerator and polynomial in the denominator, we're going to go ahead and check the degrees. So when the degree of the numerator is greater than the denominator by 1, that means that we have no horizontal asymptote, and we have to check for a slanted asymptote. So if the degree is greater by 1, that means you actually have a slanted asymptote. So we have something right here. This is n. If n is greater than 1 over the denominator, that means we have a slanted asymptote. Okay, so that can be seen as x squared over x. That has a slanted asymptote because this 2 is bigger than this degree of 1. We can try it again, x to the 5th and x to the 4th. This 5 is greater than the 4 by 1. And in scenarios where we have x cubed over x, this is bigger by 2, this is 3, this is still a 1, so we do not, just no horizontal. So let's go ahead and check this out. So similar to yesterday's, we have to go ahead and find out all the information. So let's go ahead and do this one real quick. Here you go. The first thing we got to do is find factored form. I can go ahead and see the numerator is x squared minus x minus 6, and I can go ahead and do the tabular method if I choose to, or I can go ahead and factor from what I know. So let's go ahead and practice some tabular factoring. So I got this right here, and I get my table. Here you go. I get this x squared, that will go here, x squared. Then I get this negative 6, that will go right here. And I multiply them together, I get negative 6x squared. Okay? Now I'm looking for these numbers. I'm looking for the number that goes right here and the number that goes right here. So that number has to multiply to negative 6x squared. Okay? Now, I'm looking for two numbers that multiply to negative 6x squared and add up to negative 1. So that gives me the option of 3 and 2 multiply to 6. One of them has to be negative, and they have to add up to that negative 1. So there's minus 1, there's a positive 2. So I go ahead and check what they have in common. So if I check right here, horizontal at the top, the only thing they have in common. Whoops. What am I missing here, guys? I caught myself. Negative 3 times 2 is negative 6, but I need x squared, so these need to have x's. Whoa, I almost made a mistake. Okay, cool. Fixed it. Now, we're going to go ahead and see what they have in common in the numerator, and we can see that they both have in common an x. Cool. Here, at the horizontal at the bottom, we can see that they're all divisible by 2, so I can factor out a 2. Only this one is negative, so I can't factor out a negative. They both have to have negatives. So vertically right here, they both have a common an x, and right here, notice how both of them are negative. So this is going to be a negative something. They have a 3 and a 6. Those are divisible by 3, so I'm going to factor out a 3. So what I have so far should be x plus 2 because it's positive, and x minus 3 because it's negative, divided by x minus 1. So let me go ahead and start filling in my solutions. I'm going to go ahead and give myself some space here. And I got factor form. Well, I already did that. That's this function right here. And the domain. So it's going to be all real, except for when this function is dividing by 0. So I look at the denominator. I got x minus 1. So that means this right here, I can have any number except this x value. So x minus 1 equals 0, x is equal to positive 1. So all real except when x equals 1, because if I put a 1 right here, it's 1 minus 1, 0. Can I divide any number by 0? Well, no, that does not exist for us so far. So I can have any number except for that, x equals 1. Now, what I want to go ahead and see is what happens as this x equals 1? Well, if I go ahead and notice the function, I know that holes or removed discontinuities occur when the factors are the same. If not, this denominator will be a vertical asymptote. So do you see this term right here, x minus 1 on the anywhere on the numerator? Anywhere here. It does not repeat, right? So therefore, this means that this x equals 1 is indeed a vertical asymptote. X equals 1. Okay? So do we have any removed discontinuities? Well, we just saw that nothing repeats, so this is equal to none. We don't have none here and none over here. Okay? In the factor form, in the equation that we have, let me go ahead and give myself some space. Let's go ahead and check for horizontal asymptotes. Well, I checked the degrees. The degrees 2, and the degree here, there's nothing there, but I know it's a 1 and 2. So I checked the numerator is equal to 2. The denominator's degree is equal to 1. So is the numerator bigger by 1? It is. So according to our rules, this tells me the top is bigger. So I have none, no horizontal, and I'm going to check for oblique. Now, here's the moment we need to go ahead and understand that if the degree of the numerator is larger by 1, I need to go ahead and long divide to find this equation of the slanted asymptote. So we know how to do long division. Let's go ahead and set that up real quick. This is x squared minus x minus 6. That's being divided by x minus 1. Okay, so I'm thinking of a number that gives me x squared. So what is that number that goes here? So what times this x gives me x squared? Well, x times x gives me x squared. But I got to remember that it multiplies to both. So it's going to be negative x. Cool. Okay, I go ahead and do the next part. Let me go ahead and clear some work. And the next step is I'm going to go ahead and subtract. Just like we do in division in middle school. X squared minus x squared, that is 0. Good job. Then I got negative x minus a minus, right? So if I go ahead and write out here on the side, I got negative x minus a negative x. So negative x plus x. That just gives me 0. Oh, 2 and 1. Cool. So this is a negative 6. Okay, now I'm thinking, what number times my x gives me 6? Well, if we go ahead and notice that, there's nothing else that I can do. So this has to stay as it is. So I'm finding my, I have to notice that this is all that I can do so far. So my equation is going to be this x right here. If I long divide, the equation for the slanted asymptote is y equals x, what I got from here, plus the remainder, that is this 6 right here. So it's going to be plus negative 6 over what it was being divided originally. So all of this. So I got x minus 1. So this is the equation for my slanted asymptote. So y equals x plus negative 6 over x minus 1. Another way of writing this that is completely the same is x minus 6 over x minus 1. That is also the same term, the same linear equation. Okay, so we're going to go ahead and start finding out where we can graph this. Let me see if I can zoom out here. And it looks like I cannot. So let's go ahead and start labeling. We have a vertical asymptote at x equals 1. So let's go ahead and do that. At x equals positive 1, I got a vertical asymptote. Then I saw that my slanted asymptote was the equation y equals x plus negative 6 over x. I forgot what it said. X minus 1. Awesome. Cool. So what I want you to know is that this graph will follow the behavior of this line. Now, what I want you to know is this graph will eventually behave like this line as we approach x's to positive infinities and x's towards negative infinities. So remember our pizza example. What happens as my denominator gets really, really large? My denominator eventually makes this entire part equal and go to 0. So all of this would be a 0. So all we have to worry about is this right here, this x. So my asymptote will behave like y equals x. So I need to graph that. Luckily for me, that is a linear function. So if I make a table, just to get a couple points, for the equation y equals x, I can see that if I put negative 2, negative 1, 0, 1, and 2, and I substitute them, I get the exact same values, negative 1, 0, 1, and 2, because this is just x. So I can start plotting that. This is a vertical asymptote, so I'm sorry, slanted asymptote, so I'm going to go ahead and make it dotted as well, because that's telling me my graph will have to go ahead and continue. And the way I know this graph looks like this, because if you pick a point, negative 2, that means this point right here, negative 2, negative 1, and then down to 1, 2. That's how I got this line. Or you can also see this is a linear function, the parent function, and we could also know how it looks like. Okay, so we're almost done. The last thing that we need is the same thing as yesterday, is find the intercepts. So if I go ahead and find out where this graph touches the x and y axis, I'll have a better understanding of how my graph looks like. So if I get the function and I substitute a 0, what do I get? Do I get the x-intercepts or y-intercepts? Well, if I substitute 0 into all my x's, this is telling me I find my y-intercepts. Okay, and the equation that I'm still using is the same. It's going to be x squared minus x minus 6. X squared minus x minus 6. Did I get that right? Since I still can't zoom. Oh, I figured out how to zoom. X squared minus x minus 6. Awesome. Divided by x minus 1. Cool. So we're going to go ahead and continue. And if I substitute zeros into all my x's, I get that this would be 0 squared. This would be 0. This would be left as 6. A negative 6, sorry. This would be 0, and this would be a minus 1. So I have negative 6 over negative 1, which is just 6. So this is my y coordinate. So my y is equal to 6, and my x is 0. So this is on the y-axis at 6. Okay, can't zoom anymore. Okay, never mind. So it's 0x for my x's and 1, 2, 3, 4, 5, 6. It's a little bit above right here. This is my y-intercept. My x-intercept, I can find that by setting my numerator equal to 0. So my x-intercept, so f of x equals 0. So my numerator, x squared minus x minus 6, that I saw in factored form earlier, is x. This is x. This is what? A minus 3. This is a plus 2. Then this is equal to 0. My numerator equals 0. So that means I can get each part, x minus 3 equals 0, and I can get x plus 2 equals 0. So x equals a positive 3 and x equals a negative 2. Those are also x-intercepts. So I have one right here at, sorry, my y was right here, sorry. It's above my graph, I didn't fit. But I got x-intercepts at 3, 0, and negative 2, 0. So these are my x-intercepts, or my zeros. Okay, so at 3, 0, this is 1, this is 2, this is 3, 0, awesome. And that negative 2 right here. Okay, knowing my my knowledge from these graphs, they have to avoid these asymptotes at all costs. So this graph will go ahead and go from here, right, from the left, touch this point, this x-intercept, and it'll go ahead and continue to this y-intercept, and it'll go ahead and behave towards these asymptotes. It'll get really controlled here. So same exact thing. I can't go ahead and cross this way, and I can't cross that way. So what my graph has to do is the same exact procedure. Whoops. Same exact procedure. It has to bend towards these lines. Okay, it looks a little messy. Like that. And this is how I graphed it. It really looks messy. Sorry about that. Oops. Okay, I'll provide the Desmos graph on the worksheet so you can see a better understanding of the graph. So let's find the range real quick. So how low does this function go? These arrows will go ahead and show you that it goes to negative infinity all the way to positive infinity. Whoops, positive infinity. Okay, interesting. Still not working. Okay, so from negative infinity to positive infinity is my range. Negative infinity all the way to positive infinity. Awesome. Um, the next thing that I want to know is the end behavior. Okay, so it's not letting me. So the end behavior is telling me what happens as x's, I think my graph moved, guys. Well, what happens as my x's, yep, my graph moved. So what happens as the x's go to the right? So my function is behaving like this linear asymptote. So as the function, you're finding its end behavior, it will behave like the asymptote, like that asymptote that we found that was just x. So as the limit as x approaches infinity, positive infinity, as x goes to the right, my function behaves like the parent function, the linear, which we saw is just like a little positive line like this. It will also increase. My y's will go up, up, up to positive infinity. Now the limit, can I zoom at least? Okay, I'm struggling here, guys. Trying to zoom or not. Okay, so considering the function, for the slant asymptote is y equals x. It is a linear function like this. So as x, the limit as x goes to negative infinity, the function does what? What do my y's do? Well, my y's, as I go to the left, they're going down, 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 all the way to negative infinity. Okay. Alright, class, that's how we graph these. I believe my function moved at the end, so be careful about the final graph. So make sure you notice that this should have been right here. Okay, other than that, it looks correct. Okay, thank you. Bye.